Now, the last thing that we talked about yesterday, yeah, if you got something to turn in, go ahead and bring it up here and put it in the file. The last thing that we talked about yesterday, I want to make sure that we get that, not because the actual problem is so important, but the, hold on, when did you get here?
Like 11, like the bell rang, then I walked into class on the last question.
Okay, we're going to be using the concept in some of our future problems, so I'm going to make sure that we're all clear on it. So, and that's the idea of, in our notes, on page 43, number 2, finding these coterminal angles. Because starting yesterday, we realized that our angles didn't have to be in quadrant 1. We can have angles everywhere. And we can have negative angles. And we can have big, giant positive angles. So it's important that we understand that there are lots of ways to name an angle of 100 degrees. So I'm going to draw an angle of 100 degrees. There it is. Now, remember, unless I'm doing navigation, a ship sailing or something, then I'm starting all my angles from here. So, and going counterclockwise. Standard position angles. So 100 degrees is just past 90. There would be 100 degrees. So somebody said draw a 100-degree angle. This is where I would put my terminal side. But that angle, that vector right there, that ray, could also be the terminal side of the red angle, right? And the red angle, look at how it's rotating. It's rotating in a negative direction. The red angle is negative 260. Because together, the red and black have to make 360. Right? So these are called coterminal angles because their terminal side, where they stop, is the same ray. That's what coterminal angles are. Now, I could draw infinitely many coterminal angles. For example, what if I drew that blue angle? Isn't that blue angle also coterminal? Yep, it's in standard position and stops at the same place as the others. So it goes all the way around and then the 100. So what's the measure of the blue angle? 460. So that's what we talked about yesterday, that coterminal angles are found by taking whatever your original angle is, in this case 100 degrees, and either adding 360 to it, hence the blue, or subtracting 360 from it, the blue. Now, if you wanted more, you could add another 360 or subtract another 360. You could just keep doing that forever and ever and ever. That is written like this: 100 plus or minus 360 n. And n is a whole number. It stands, so it's like 1. So you could add or subtract 1 360, or you could add or subtract 2 360s, or 3 360s, however many 360s you want. So in the notes, it said name 1 positive and 1 negative. So 100 plus 360, 100 minus 360, and we were done. But another time, you might be asked to list all of the coterminal angles. Well, you can't list them all. They go on forever. So we write it this way. Does that make sense to you? Plus or minus 360n. if the angle is in radians, so let's say the angle is, well, we have one, 2 pi over 7. Obviously, you're not adding 360 because 2 pi over 7 is a radian and 360 is a degree. But the idea is the same. 360 is a revolution. So you are going to add or subtract multiples of revolutions. So that's going to be 2 pi n. If you want 1, you'll add 2 pi or subtract 2 pi. If you want 2, you'll add or subtract 4 pi. 2 pi's. And so on. So this is how we write all of the coterminal angles if you are asked for that. To get 1, you just add or subtract a revolution. Okay, now we're on to number 3. That we kind of talked about yesterday a little bit. So hopefully you'll be ready for that question if and when you see it. Now, tell the sign of the sine, cosine, and tangent, so SIGN, so plus or minus, positive or negative. Tell the sign in the interval from pi over 2 to pi. All right, let's talk about that for a minute. Remember, in standard position, angles are measured like this. That's standard position. They start at the positive x-axis and they go counterclockwise. What would those labels be in radians? Instead of degrees, I've used degrees there. What would they be in radians? Well, 0 is 0. What's 180? Pi. So what would 90 be? If 180 is pi, 1/2 pi. We normally write that pi over 2, but if you said 1/2 pi, that's the same thing. So we got a 1/2 a pi, we got a whole pi. What would this one be? 1.5 pies, or 3 pi over 2. And what's 360? 2 pies, sure. So now we've labeled it in radians and degrees both. So when this problem says, tell me about the sine, cosine, and tangent in this interval, what are we talking about? What interval are we talking about? Which quadrant is pi over 2 to pi?
No, it's like 2 hours late.
Isn't it quadrant 2?
Yeah.
It'll be a quadrant 2 to pi. And in quadrant 2, every point is negative x, positive y. Agreed? That's 7th grade, right? Negative, positive. Now, remember that sine is associated with y, and cosine is associated with x. Now, before you start getting confused, look at your yellow sheet. How is sine defined? Not opposite over hypotenuse. What's the other definition of sine? Y over r. R is always positive. R is the hypotenuse. It's the radius. It is always positive. So the SIGN of the sine depends totally on y. The SIGN of the cosine depends totally on x. So when we want to know, is the sign positive or negative, in this quadrant, the sign is going to be positive. But the cosine is going to be negative. Now, what about the tangent? What does your yellow sheet say about the tangent? Y over x. So the tangent depends on both of them. Sine is y, cosine is x, tangent's both. So what happens if you put y over x, positive over negative? What's gonna happen? You're gonna get negative. So in the second quadrant, the sine is positive, the cosine is negative, and the tangent is negative. Does that make sense to you? See what's happening? Depending on the quadrants and the coordinates. So when I look at the next one, it says pi to 3 pi over 2. All right, well, which quadrant are we looking at then if we're pi to 3 pi over 2? Down here? Quadrant 3? And in quadrant 3, every point is negative x, negative y. So tell me about the the sine. We'll start with doing the same order. Tell me about the sine. Down there in quadrant 3. Negative. If y is negative, sine is negative. Tell me about cosine. Negative. And tell me about tangent. Positive. Because when you put y over x, the negatives cancel. Okay, now we're being a little bit more specific. Now, we are going to find the sine of these. So, wait, you are not figuring out a number. So you're not going to say like root 3 over 2 or something. You're just going to tell me if it's positive or negative. So the cosine of 8 pi over 9. What do you have to figure out? Where's 8 pi over 9, right? Because that's what it depends on, which quadrant am I in. Let's think about that. That's 8/9 pi. That's more than a half, but less than a whole. Pi I'm talking about, more than a half pi, less than a whole pi. So isn't this in quadrant 2? And if it's in quadrant 2, then x, cosine, is x. X is negative, right? Did you follow all that logic, step by step there, thinking through that problem? Cosecant, negative pi over 7. All right, first of all, it's negative, so that means we're starting here, but we're going down. Negative. Now, I don't have any negatives labeled. What would this one be? I'm sorry, this is 0. I'm starting here and going down. What would this one be negative-wise? Negative 90? Or negative pi over 2? So I'll just write that here. Negative 90, negative pi over 2, if I'm going negative. Now, would you agree that negative 1/7 pi is somewhere in here? Because isn't 1/7 less than 1/2? So this is in quadrant 4. Okay. Cosecant is a reciprocal function. What's it the reciprocal of? Cosecant is the reciprocal of the sine. Sine is y. And in quadrant 4, y is negative. So first of all, negative pi over 7 is in quadrant 4. If you go all the way to here, you're negative 1/2. 1/7 is less than 1/2, so it's in here somewhere. Cosecant is reciprocal of sine. Sine is associated with y. So that's how we got negative. Oh my lord. Cotangent 25 pi over 8. That's a big angle. Let's write that as a mixed number. What's 25/8 as a mixed number? 3 1/8. So this is the cotangent of 3 1/8 pi. What's
I'm
you
just
for?
looking for my lanyard.
That's what I want to
Oh, Mary Kate.
I know.
God bless you.
Have a good day, guys.
Okay. Now, let's think about this for a minute. Would you agree that that's more than one surround? Because one surround is how many radians? 2 pi. So this angle, if I were to draw it, would go all the way around. And then how much more? You go 1 1/8 more. I'm talking about 1 1/8 pies. So if it went all the way around, and then it would go, there's a whole pi. Wouldn't that put me down here in quadrant 3? If I go all the way around, that's 2. Halfway around, that picks up the 3rd pi. And then I have to go 1/8 more. So this angle is in quadrant 3. In quadrant 3, x and y are both negative. So what happens when I build the cotangent? Positive. Because isn't cotangent x over y the reciprocal of the tangent? And if they're both negative, then the cotangent will be positive. Oh, now we're in degrees. Sine 152, that's a little easier for you probably. Sine 152, which quadrant is 152? Use your degree measures now. 152 is in quadrant 2. In quadrant 2, y is positive, so the sine is positive. The sine of 152 is positive. Okay? If you had to go home tonight and explain to your mom, who desperately wants to know why the sine of 152 is positive, how will you explain that? How do you know the sine of 152 is positive? 152 is in quadrant 2. In quadrant 2, y is positive, and sine is y. That's it. It's that easy. Tangent, negative 200. I'm a negative angle. Where is negative 200? Now remember, if you're going negative, you're going down. Where is negative 200? Quadrant 2 also? And this is a tangent. What do we know about the tangent in quadrant 2? It's y over x. And since one of them is positive and one of them is negative, the fraction will be negative, right? Uh-oh. Secant 500. What do you know about 500? It's more than once around. So if I were going to draw 500, I'd go all the way around. And how much more? 140. Puts me back in quadrant 2 again. And I want the secant, so I know I'm in quadrant 2. Everybody okay with that? All the way around, another 140, because it was positive, yep. I want the secant. Secant is reciprocal of cosine. Cosine is x, and x is negative. So the secant of 500 is negative. If you type that in on your calculator, you get a negative number. So far, so good? All right, now we're getting at the real meat of it. Now we're going to find the sine of 150 degrees. This is the lunch period. I'll try not to get too carried away.
Wait, so is the secant x?
Secant's reciprocal of cosine. Cosine is x, so secant's x. And I don't, when I say secant is x, that isn't really what I mean. I mean secant is associated with x. Secant is r over x. So it takes on the sine of x, the SIGN. All right, sine 150. All right, so the first thing you're going to do is draw 150 degrees in standard position. Okay, we know how to do that. You're going to start right here. And you're going to go around over to here, right? Why am I going over to there? Because straight up is 90, straight out is 180, and 150 is in between. So here's my angle, 150, right there it is, 150 degrees in standard position. Now I'm going to drop that perpendicular straight down, creating a right triangle sitting on the x-axis, one of my butterfly bow tie wings, right? And if that's 150, this little guy, which is called the reference angle, is how big? How big would that be? 30? Guys, this is 180, right? So doesn't it make sense that this would be 30? Whoa! There's a 30 and a 90. So this has got to be 60. What are the sides of that triangle? Well, across from the 30 is 1. Across from the 60 is root 3, and the hypotenuse is 2. Now, if you're going to make a mistake, here's where you're going to make it. See that root 3? He's negative. Why is that root 3 negative? We're going left, right? We're in quadrant 2. X is negative. Anytime you're not in quadrant 1, something will be negative. Maybe both of them, but something will be negative. What will never be negative is the hypotenuse. That number is always positive. But these two can be negative depending on where you've drawn your triangle, okay? Now, in this case, it isn't going to matter because we want the sine, and the sine is opposite over hypotenuse, so the answer to the question is just positive 1/2. We did problems like that before, only they were in quadrant 1. So we're basically doing exactly the same thing, we're just doing it in different quadrants. Cotan, 5 pi over 3. Let's change it to degrees. Remember how to do that? What's pi? 180. Divided by 3 is 60. Times 5 is 300. So this is the cotangent of 300 degrees. So we're going to go ahead and draw 300 degrees. Here we go. Now I've done so many of these in my old life that that's just automatic to me. Do you all understand why 300 is there? Because this is 90, 180, 270, 360, 0 and 360. So 300 is somewhere between 270 and 360. So I make my triangle. And if you want to add to my gray hair, draw your triangle this way. Never do that. That will set me off. Your triangles always get attached to the x-axis. Reference angle. Now remember, that was 300 degrees. That is 300. How much would this have to be then? 60. Here we go again. That's a 60. So isn't this root 3? And 1 and 2? What's negative? The root 3. This is positive. We went right and down. Down is negative. Now we want cotangent. I can't ever remember. All I can remember is it's the reciprocal of the tangent. Tangent is TOA, opposite over adjacent. So this will be adjacent over opposite. Does that make sense to everybody? Maybe you have it actually memorized. So what would adjacent over opposite be in that triangle? Remember, this is your angle right here. That's the angle you're looking at. So this is opposite, and this is adjacent. So 1 over negative root 3, or negative root 3 over 3 is our final answer. I would like you to try C and D. See how far you can get with C and D. I've got answers up here. I don't know if they're right or not. I'm going to wait for you to check them and tell me if you agree or disagree. Pi is 180. Divided by 4 is 45. And 45 times 3. I think that math is right. That's 135, right? I want you to make sure that my number is right and my SIGN is right. My positive or negative is right. Did anybody get root 2 for the first one? Root 2? It's actually root 2 over 1, but I just wrote root 2. Root 2 over 1 is fine if you want to write it that way. Because cosecant is reciprocal of sine, so it's hypotenuse over opposite. So assuming my triangle's right, it would be root 2 over 1. Did everybody get a 45-degree reference angle here? So are you telling me then we have no questions about this problem? We're all good on that one.
So you know that that's supposed to be negative because it's on the negative
Side of the x-axis.
Okay.
If you're going left and down, you're negative.
So whichever one's perpendicular to an axis is, and then it's the one that's negative. Like when that y was going down, we had the triangle that was upside down.
May, I don't know what you're thinking about. I want you to just do what you already know. This is quadrant 2.
Mm-hmm.
X is negative in quadrant 2.
Mm-hmm.
X-axis.
So whichever one's on the axis.
That's Y.
Okay.
Y is up and down.
Mm-hmm.
This is X, this is Y. If I was going to plot this point, I would go left. This is the origin. I'd go left and up. Left is negative, office policy.
Okay, so like, the -1 is according to point pretty much?
Yes,
Okay.
that's exactly what it is. It's the ordered pair.
Okay, thank you.
All right, what about this one? Did you get this drawn in quadrant 2? Did you get a reference angle of 60? Because this is 180, right? Labeled it that way. Tangent is opposite over adjacent. I got -√3 or -√3/1. Okay? All right. You can go to lunch as soon as you do problems E and F. Compare your answer with a neighbor. Agree. Then you can go to lunch. If you don't agree, you gotta work it out. And it's problem E and F. All right, you three need to talk to each other about your answers so you can share your answers with each other, okay?
Wrapped up chapter 1 pretty well. We talked about the characters process chapter 1, the 4 characters that we actually need.
Mrs. Ford, I was wondering, how do you know, like, what the degrees is again from the 7 pi over 6? How do you know what the degree is for the circle?
Okay, well, you remember that pi is 180.
Oh, right.
180 divided by 6 is 30, times 7 is 210.
Okay, got it. Thank you.
We're gonna have to do that without a calculator. Yep.
I'm having some trouble, like, so I know what to do, but what I don't know is which angles are what, like, what's opposite, what's adjacent, like, what angle is it based off of?
The one at the origin. Always the one at the origin.
So, like, 210?
No. Because you're gonna draw 210. Did you guys get it sorted out? All right.
Yeah.
When you draw 210, you have to form your triangle. This is the angle right here. How big is it?
Oh, the 30 degree?
Exactly.
Alright.
Because you're looking at the triangle now. Okay? The sides of the triangle. You check your answers with somebody?
you're right. And that's gonna be 60 here.
She just said you're right. Honey, they're on the board.
So then, it'd be, yeah, that's great. That's what you got.
Lunch, man.
Yeah, have lunch. You guys get together? Alright, for lunch. The answers are up there on the board if you have not yet figured it out. Yes, Ryan, the answers are on the board.
What time do you want us to be back?
25. All right, with 25, and everybody's back at 25. All right. Oh, I need to turn this off. I did that already today.